Good afternoon. A warm welcome to one and all. Today's guest and eminent speaker, Mr. Rajaram Desai, sir. He is a senior project manager on Unnat Maharashtra Abhiyan. Dr. A.C. Attar, sir, principal, Karvar Vahrao Patil College of Engineering, Satara. In charge, head of the department, Professor Ajay Sharad, sir. Oshim Dharak, ma'am. She is the junior project manager on Unnat Maharashtra Abhiyan project. We are organizing committee members, respected delegates and participants from all over Maharashtra, and the representations from various institutes affiliated to Unnat Maharashtra Abhiyan. Dear teachers, professionals, social workers, and students. I, on behalf of Rajaram Shikshan Sanstha's Karvar Vahrao Patil College of Engineering, Satara, cordially welcome you all for today's webinar. Before we proceed, as a tradition, we used to pay homage to our beloved Anna, that is Padma Bhushan, Dr. Karvar Vahrao Patil. Also, we take opportunity to pay homage to Bharat Ratna Dr. Babasaheb Ambedkar and Chhatrapati Shivaji Maharaj. I, on behalf of all of us, take this opportunity to pay homage by offering flowers to their portraits. Department of Civil Engineering, in association with Unnat Maharashtra Abhiyan. Unnat Maharashtra Abhiyan is a project of the Ministry of Higher and Technical Education. Also, in collaboration with Center for Technology Alternatives for Rural Areas, Sitara, specific department of IIT Bombay, are organizing this webinar, the JalTantra story of an award-winning innovation through engagement with stakeholders. Well, this JalTantra is a story, as it has been rightly mentioned in the topic itself, that it is an innovation that is being governed by an IITian. As students and faculty interact with development sector problems through academic and professional engagements, more opportunities are created for analysis of problems. Synthesized innovation can be boosted, and one of the avenues will be entrepreneurship, if proper ecosystem is created. JalTantra, the water network design and optimization system, is one such award-winning innovation developed at IIT Bombay. Through collaborative efforts, mainly through Sitara and CSE department, with support from other departments as well. So here, we are fortunate to get this opportunity to host the webinar on this event. So I request Dr. A.C. Attar sir, our beloved principal, to give a brief overlook on our parent Rajaram Shikshan Sanstha, Institute, and the department as well.
Thank you, Tapas sir. Resource person of today's program, Rajaram Desai sir, HOD Civil Engineering Department, Shelar sir, Coordinator Tapase sir, all the faculty members of the Civil Engineering Department, and all my friends who are attending this particular program. So today, first of all, I am very much thankful to IIT Mumbai as well as Unnat Maharashtra Abhiyan for giving us opportunity to host this webinar. So this Unnat Maharashtra Abhiyan is based on total the society activities, and if we go to the history of Rajaram Shikshan Sanstha, it is very much attached to society. The founder of Rajaram Shikshan Sanstha, Honorable Karvar Anna Patil, so he was well connected with the society, and in those days he established this Sanstha for the development of the society itself. And he was believing that if we provide the education to the rural masses, then there will be the upliftment of the society. So that's why he started the Rajaram Shikshan Sanstha. And in those days, there was the problem for educational fees. So he started the Eat and Learn scheme. And through this Learn and Learn scheme, n number of students literated through this Rajaram Shikshan Sanstha. As well as there is a very good society. Rajaram Shikshan Sanstha is running 70-50 schools all over Maharashtra, and 43 colleges. So now this Mokhada, we have the college at Mokhada also, where this Unnat Maharashtra Abhiyan is running their project. So this particular Reyes Shikshan Sanstha today also working for the poor people as for the development of the society. And the entire base of the Reyes Shikshan Sanstha is the development of the society and providing the education to the rural masses. If we go through the Karmal Bhaurao Patil College of Engineering Satara, it is established in 1983 and we are running this college for last 36 years. And again, each and every department, we have 4 departments: engineering department, computer engineering department, electronics engineering department, as well as mechanical engineering department. And here also we have a culture of multidisciplinary projects, and students are working on different projects in connection with industry. So we have the very good base of MIDC in Satara. At the same time, we have the very good connect with the Jilla Parishad Satara as well as Public Work Department, Jivan Pradhikaran, and the students are doing the projects with the help of this. At the same time, we are providing the consultancy, third-party audit for Jalukta Sivar as well as Jilla Parishad Satara. We are doing the testing work of Jilla Parishad, PWD. Again, we are providing the third-party audit as well as the all civil engineering consultancy to Reyes Shikshan Sanstha itself. This civil engineering department is aggressive at providing the consultancy services to the society. And if we go through the projects done by the civil engineering department, I think more than 80% projects are societal projects. And actually students are working on the live projects. So I think so it is a very good connect with the society from college point of view as well as student point of view. Whatever the intention of Sitara as well as the Unnat Maharashtra Abhiyan is there. So already our students as well as our faculty members are aligned with this particular motive of Unnat Maharashtra Abhiyan as well as the Sitara of. So I think this particular college is well connected with society and it will fulfill the dreams which is decided by the Unnat Maharashtra Abhiyan in future also. And we can work together and our students will be benefited. Already we are working. So in future also we will conduct a number of projects in association with Unnat Maharashtra Abhiyan and as well as Sitara and IIT Bombay. I am very much thankful for giving me the opportunity to say my few words on this particular platform. Thank you very much.
Thank you, sir.
Over to
Thank you, sir. It's like the Reyes Shikshan Sanstha definitely has a social awareness since its inception. I request all the other participants to mute their mic, please. Okay, fine. Without wasting much of your time, I request the coordinator, Professor Swati Jagdale Madam, to introduce our today's guest of honor, Mr. Rajaram Desai, sir.
Good afternoon, ladies and gentlemen. On behalf of Department of Civil Engineering, Karmavir Bhaurao Patil College of Engineering, Satara, I, Mrs. Swati Jagdale, pleased to welcome you all in today's webinar. It's a great pleasure for me to introduce our guest and resource person, Mr. Rajaram Desai, today, who is going to talk to us about JalTantra, tool for optimization for piped water network. This is a subject in which we should all be deeply interested. Mr. Rajaram Desai was born in a small village in Kolhapur district. He has a bachelor's degree in chemical engineering from IIT Bombay. While working in research and development in core field of chemical engineering, he continued to work on community initiatives for tribal and underprivileged sections of the society, which include 2 documentaries. One is Tanda and second is Pani Panchayat, made by Tata Institute of Social Sciences. Later, he worked and lived in USA for 10 years before returning to India and joining Sitara Center for Technology Alternatives for Rural Areas, IIT Bombay, in 2012. He led many initiatives at Sitara, the first and foremost among them being the bulk water grid, an innovative and sustainable solution for over 1 lakh tribal population of Mokhada Taluka of Palghar district, facing severe scarcity in the vicinity of major reservoirs supplying water to city of Mumbai. It was during this period that JalTantra was developed through continuous engagement with all the stakeholders to understand the requirements of practicing engineers and incorporate their feedback and suggestions. Besides this, he played a key role in successfully executing professional engagements with Palghar and Thane district administration for third-party technical inspection of government programs on water conservation and rural water supply. Currently, leading a major initiatives called Unnat Maharashtra Abhiyan involving several engineering and technological institutes in Maharashtra state. This initiative is aimed at reforming engineering education and research and aligning it with development needs of our society. Its objective is improving outcomes of government services through third-party technical inspection, process improvement through feedback mechanism, giving impetus to innovations, boosting the entrepreneurial activity among the engineering students and faculty, community, and technology transfer for rural development. Also, leading two projects sponsored by Tribal Development Department, Government of Maharashtra, in collaboration with selected Unnat Maharashtra Abhiyan institutes for skill development and entrepreneurship training and technology transfer for tribal development for selected focus areas. Ladies and gentlemen, please join me in welcoming Mr. Rajaram Desai. Sir, please, I would request to share your knowledge and wisdom with us.
Thank you very much, Jagdale madam. First of all, I want to take this opportunity to thank Dr. Attar, Dr. Shelar, and Dr. Tapase for giving me this opportunity in your esteemed institute, which is named after Karmavir Bhaurao Patil. As everybody knows, in Maharashtra, the contributions made by Karmavir in giving education to rural masses and the deprived sections of the society. And at that time, he introduced the principle of earn while you learn. I mean, that is a foresight that he has. And now, as you said, that it has expanded, all over Maharashtra. So the huge contributions which are there. So it is, I consider this as my privilege to be here and share my experiences with you. First of all, now, as Sitara, as you know, is an academic center in IIT Bombay. It is established in 1985, and it is focused on core areas of action research on water, energy, agriculture, livelihood, health, education, etc. And it is also focus is on the bottom sections of the society and unprivileged sections of the society. So in that respect, I mean, more focus is on the Adivasis and rural masses, their problems, and address through the interaction through the use of technology. Now that is the basic focus, and the pedagogy or the method that we use is basically the real stakeholder, real problem, field work and case study. That is the mechanism that we use to do the research. Now while working at Sitara, now this Unnat Maharashtra Abhiyan, basically as you have already introduced, but I want to stress it that because it's today's topic about the innovation, which has won the Impactful Research Award at IIT Bombay. So what we are saying is that the higher and technical education should be connected with the development problems of our society. And we all know that, in the same area, like whether it is a water, energy, livelihood, agriculture, whatever problems are there, when these higher and technical institutes, we have such a large pool of manpower and so many institutes, if that is connected with them, not only through voluntary efforts, but through the formal mechanism, that is, the through academic space is created for new education, to new research, and new innovation, that will be through is the direct engagement with these sections of the society. We can actually go there, find out the actual problem, analyze them, and come out with different innovative solutions. And there will be multiple mechanisms to interact with and make the development possible. So one of the things that we already introduced is the third party technical audit of some of the services that we already know, that whether it is a rural water supply or other things which are there. And now we are going into MSME, then agriculture, power, etc. So that is one area. Second area is that as we develop innovations going forward, we will develop some entrepreneurship. So that will be the new opportunity. And the third is the dissemination of this technology for the actual upliftment of the people in rural area. So that is the basic objective. And in that context, I want to take this, innovation through stakeholder engagement about JalTantra, and also the sustainable solution that we are working on for the people of Mokhada. So let us move. So the journey started when I joined in 2012. So that time, the question that we are actually grapple with is basically Shahapur and this Mokhada Taluka and Jawhar, they are predominantly Adivasi Taluka. Mokhada has maximum population, 92% Adivasi, and Mokhada and Shahapur, they house the major reservoirs. This is the old Thane district. You can see that Shahapur and Mokhada, they house the major reservoirs that supply water to Mumbai. And in their vicinity, there are many villages that are tanker feed villages. And there were about 60 villages, they have been, dependent on tanker water for more than 3 years. So why this contradiction is there? Why this, this kind of situation is there? That was the question that we had. And one of the things that we thought that let us first, see, let us do some mapping. Let us see what are the different schemes which are there, drinking water schemes. And one of the things that we can do is that extend the neighborhood schemes or augment them and provide water to these villages. So that was the initial thought. And I remember in the month of May 2012, I went there with 3 students. And then this was with this idea. Next slides. And then, so this is the problem you can see about Maharashtra's, drinking water shortage in many parts of Maharashtra that we know. And in Thane, that is Thane and Palghar, about 210 tanker fed villages there. And in Mokhada Taluka alone, 30 villages or 70 habitations, tanker fed. And as I said, there is in spite of heavy rainfall and big reservoirs, and this problem continued. So there was this challenge, and at least to start with, we thought we can let us look at this, just extending this existing scheme to these tanker fed villages. Next. So then we went there and we just mapped this. We took the data from MJP and Rural Water Supply Department, and what we found is that most of the rural regional water supply schemes are there on the western side, and most of the tanker fed villages are on the right hand side. This is what the first some striking contrast that we observed. And so we tried to identify some schemes which could be there in that neighborhood of these tanker fed villages. So we went to Mukhada. So there was a couple of schemes. One was the Suryamal scheme. And then we observed that because of the terrain, we cannot take it to other villages. And another scheme was Karegaon scheme. And what happened is that time, this new Middle Vaitarana project was under construction, and that was supposed to supply about 455 million liters of water to Mumbai, and that the source of this Karegaon scheme was being submerged, and therefore that Karegaon scheme was going to be revamped. So when we went there, we found that there is a cluster of 13 tanker fed villages in the vicinity of Karegaon scheme. So one thought that we came to our mind, why not include these 13 villages also when we are doing this revamping of Karegaon scheme? But it was, government norms and other things, it was not possible. So that was the problem. So we thought that let us try to at least work out a solution. Next slide. So we undertook that as a problem, and main thing was like motivation is like, what are the possibilities? So the lower, that middle Vaitarana, the level of that middle Vaitarana, one of the problems when discussing started with MJP and rural water supply is that lower water, middle Vaitarana level was much lower than the level of these tanker fed villages, and pumping water from middle Vaitarana was not feasible because there are certain norms per capita spending as far as the scheme is concerned. So that was the one problem. Then we started exploring what could be the other sources. So in that exploration, we found that there is a Upper Vaitarana reservoir in the same area, and that can be offer critical advantages as a source, because one of the things that we observed that Upper Vaitarana level is 503 meters and the average elevation of the villages is 391. So it was possible, we thought, to provide villages which are located at different elevation. Some of the villages are located very high elevation. That should also be possible. And then whatever the energy cost, because of which this was going to be not feasible, so that could become feasible when we choose Upper Vaitarana as a source. And so another thing is that if we have a gravity flow, that will even more, both in terms of capital cost and energy cost, that will become feasible. So that is the thought process at that time. And accordingly, we started working on it. Next slide. So next. So these are the details of those tanker fed villages we actually found in that neighborhood of this Middle Vaitarana reservoir. Next. Next. So then what we thought, actually, we engaged Nikhil Huda, who was a PhD student working under the guidance of Professor Om Damani. So we thought this is a good opportunity for him to explore some kind of innovation in this while designing this one. So first thing we started is that if we have to find the innovation, first we have to understand what are the practices followed by MJP and rural water supply. So that was the first thing that we did. We went to MJP and started talking about it. If we have to design this scheme, it should not become like a academic exercise. It should have a practical value. And therefore, when we went to MJP, then we started understanding their methodology and their protocol that they are actually using. So this is just a just a schematic diagram of multi-village pipe water scheme, which all of us are familiar with. There is a source, jackwell, then what WTP, MBR, ESR, and other villages, etc. Actually, so these things we are all familiar with. But to design this scheme, what kind of a methodology they have been using? So we started understanding their process. Next. So these are the simple thing, like you select the source, then you do the population and demand forecast, then water treatment plan, mass balancing, reservoir sizing, pumping machinery, elevated store reservoirs, distribution network, and finally you do the unsteady state or extended period simulation using IPANET. So that is the general design step. Next. So we started actually exploring the process that MJP uses, and through that interaction, actually almost 2012 and 2000, later part of 2012 and 2013, we were interacting with MJP. We made some designs and we went to them. We got it reviewed, and there were a lot of tips that they had given, and we incorporated those tips. And then while doing that, we came across many problems that were actually used by, problem encountered due to the use of branch tool that they were used. Next slide. So this is just the elaborated design protocol that MJP was using. Next. So this was the scheme layout. So once actually we designed this based on MJP protocol, then we wanted to present this solution that to the stakeholders, that in 2012, May 2012, we had a stakeholder day. So Professor Soni and myself, we presented this solution to those people, which we had designed for 13 villages. And we invited all the stakeholders over there, all the local politicians up to MP, then all the administrators at Jilla Parishad, collector office, MJP, rural water supply, the NGOs working over there, common people, activists. Everybody was invited in this one. And we presented that it is possible to have a sustainable solution for these 13 villages based on this Upper Vaitarna. So that was presented to them. Next. So this was just, Chintaman Vanaga, who is MP that time, he had also come. And we had really lively, good discussion. And then once we presented that, lot of people came next that said that yes, we want IIT to do this thing for us. And then we said that we have just done a design and the report, but the actual process you have to take forward. And then we advise them that they have to make this Gram Sabha resolutions, then Panchayat Samiti resolutions, all these kind of things. And then it went through all the government processes, and then it will be taken up into the district committee. Next. So what we did now, there were 17 other villages in the north side. So they said that we also to be incorporated into this one. So you can see that this Mokhara Taluka, more than 50% of this one was tanker fed. So then we had incorporated all these 30 villages in the next phase of design. So that was the going on. Next. So during, as I said, that branch software was being used by MJP and rural water supply, and it has lot of issues. So while they had encountered some issues, but when we are designing it, when Nikhil was working on it was so many issues that came forward. First of all, that was like old technology developed in 1991 by World Bank, and it's based on DOS. So to run that, it needed DOS emulators, and also there is a difficulty in installation on personal computers. Next one was that it has a severe network size limitations. About once it goes about 100 nodes, actually it will start performance degraded severely, and no optimal performance it gives. Then many times it has have erratic behavior. Also there were some bugs, so some length actually it will bomb, and if some round figure was submitted, then it will work. And lastly, there is no improvement possible. So new features or whatever the pain points which were there, that is very difficult to resolve them within that particular software. So that was the time then Nikhil thought that, yes, he started working on a different tool, and then the philosophy was, why not? I mean, we address these issues which are there, and then have some, with the state of art technology, we can develop this, which is robust, which is open source, which is like extendable, and it can be accessible from anywhere. So that was the thought process at that time. Next. So basically, then he has to actually, from his computer science background, he wanted to, then as I said, it has large network, it should be able to handle and easy to use interface, and the other technologies also, GIS, it should be able to leverage. So that is how the initial kind of a thought process was developed, or the problem statement was developed, and then it was decided that step by step this tool will be developed. First is like focus on the branch functionality. Next. So basically what you all know that branch, when you use branch, what is it doing? It is trying to optimize the cost of the pipes. And how does it do that? Basically hydraulics is, based on the hydraulics, what happens is that when you try to reduce the pipe size, then the frictional losses will increase, and then at a particular point, that optimum pipes will be determined, so that the whatever head that you want at the end, if you want to keep that, then you cannot go below this one. So this is the general formulation. It is a lot more than that. But first is, you can say that the cost which is there, that we are trying to optimize for all the pipes in the network. Secondly, at every node you can see that what is the pressure at that node will be determined by the source head, and then its elevation and the frictional losses. Third one is that, in any between two nodes, typically you use one pipe, but general formulation, it was assumed that it can have n number of sections. And the fourth one, how do we calculate the head loss? That is just the Hazen-Williams equation. So this was the general formulation initially set for this particular tool development. So I will not be going into the, I don't know also the exact technical details, but just to give you the idea, overview of what is happening, the concept which are actually incorporated, that only I wanted to give. Next. So based on this, I mean, while there was a designing and then new system is being designing, first JalTantra, that was a name for this tool, was deployed in September 2014, and it was developed in Java, and it is a platform independent, you know, stable and sturdy, and it is also available for free download. And then if you look at the performance, we'll show you that there is no network size limitations for this tool. It is capable of handling network having as high as 1000 nodes and solving it in a few seconds. And the optimization, proven optimization algorithm was developed by them, and extension customizable. And you know, integration with other things, as we said, the GIS and other things is possible. And so that is how the first version was deployed. And again, as I said, next, that we went to MJP. This is the performance comparison we are showing. Just you can see that the performance of this particular tool is more 100 times, 200 times, like that. In those kind of the order of magnitude actually tested in various schemes that we are working on, and including Mokhada, which had that time 37 nodes. So that is the first, you know, very encouraging thing that happened, that the performance of this one, this particular tool, it beat the branch performance by a multiple order of magnitude. Next. So then, you know, first we did it, we did the demo of this at MJP office, and that time Mr. Mahesh Patil was the executive engineer. He was also very technology savvy, and he actually liked this idea, and they encouraged this. And then other stakeholders also we incorporated, especially one executive engineer, Mr. Gavankar, and his team. They got engaged into this tool development and testing from January 2015 onwards. Same again, feedback from other engineers, other professionals, and then you know, different state engineers. We got the different types of feedback and then requirements and what kind of enhancements. So based on their suggestions, based on their feedback, based on their ideas, further developments were taken up. Next. So, and then 2017, that was the final version was published. But as I said, that initial, just the pipe cost optimization was done. And next, you know, so other components of that network, for example, ESR. So what MJP or other people were doing, that the location of the ESR, that was used by intuition and by their judgment and experience. So typically each village will have a ESR, and then there is staging heights and all that. Also there are certain norms which are being used for that. And instead of that, it was thought, let us include this into programming as well. That was one thing. Then pumps and valves, that also into incorporating that into the design process. The third idea that excuse me, Gavankar suggested, that he had experience in rural water supply. He said that we design schemes as continuous basis for 24 hours. But in actual experience, what happens that ESR gets emptied out within 1.5 hours or 2 hours. So why not actually design the scheme as intermittent operations? You can decide the supply hours like 2 hours, 3 hours, like that. And based on that, then you can actually, then once people get used to it, then you can actually make it continuous. So then instead of designing it is like 24/7 or some with some typical peak factor of 3, we can design as a customizable, like depending on the actual performance of the how people use it on the ground level, and based on that we can design that system so that people are assured of water for certain number of hours. So that was one of the things. Then when there was an interaction with Rajasthan engineers, they had also in Rajasthan, it is just gravity based schemes are not, they are not able to work on that. So there may be some times that pumps may be necessary. Even in Mokhada schemes, one of the things that we found that there were some villages like Kiniste, which has very high elevation, 460 elevation. So one thing typically is that you raise the height of ESR or MBRs accordingly and then provide that just because of this village, which will increase the overall cost. So instead of that, why not? Can you try out a pump at that particular village and provide additional head to that this thing. So such kind of various kind of different parameters, and there through the programming you actually decide, let that program tool decide that what is possible and what is not possible, and then come out with design options. So that is how basically various feedbacks into this, they were taken into consideration when this tool was developed and enhanced at various stages. Next. So this is just a web application interface that we have. Next. And then, as I said that earlier, the GIS integration was done also based on some suggestions. So every time what is to happen is that, so you manually enter all the data for the nodes, pipes, etc. Instead of that, on Google Earth, you can mark the entire network, and then based on the topography of that region, you can actually mark mark the different sections or different sections of the network, uh, so that many times it is said that it should be along the road, there are valleys and hills and all that, you can avoid that. So you can actually see it and mark it, and then elevation and then length and all that is automatically calculated, and finally one input file can be actually prepared, which can become that can be fed, and then it will come out with the solution. So this is how basically various stages of the development took place. Next. So as I said, right from the beginning, the real world feedback was incorporated. So first, as a 1.5 year or so, we interacted with MJP, continued to take their feedback and suggestions, and then current practices, we understood that thoroughly, we documented that process, and I identified the areas where we can see for the intervention, on where we should focus our attention. And then third, as I already said, features like GIS integration, pump optimization are basically requests from many engineers that we interacted with, which have already big experience on the rich experience of working on developing design multi-village schemes. Next. So this is how. So here it is more elaborate. We can give some timeline actually. So in the January to April 2014, we are working with MJP, reviewing their feedback with rural water supply. Then improvement on the design with branch and simulation with IPANET. So that kind of a thing that were done. And then in 2014, this testing of the tool with smaller schemes. And the first version was deployed in September 2014. And October, we did the demo to MJP. And then Gavankar and his team, Mr. Cowley, I should mention his name because he had been continuously involved at that time in testing and giving feedback. And then 2015, we presented to almost 70 Jala Swarajya 2 engineers when there was a meeting, and they started giving feedback. Their user group was formed. And then also along with this, some of the people who had a rich experience, for example, Pradeep Gokhale, he was a superintendent engineer MJP, and he had designed a scheme in Amravati in 163 villages. So he was like, now he has, after retirement, he has a consultancy firm, which is a Primo consultant, and that has designed a scheme for Shahpur Taluka based on Barvi Dam. And we had a lot of interaction with him, both on that scheme and here also, on this particular tool, JalTantra, they used it and they give very, very valuable feedback. And the first version that JalTantra went live outside IIT was 2015. And while these external testing was going on, internal, a lot of MTech students, then technology and development solution cell, engineers, other departments, other people collaboration, they were also testing it and making enhancements. And then, as I said, February 2017, latest version was deployed. And then, various input and output format, then addition of pressure reducing walls, etc. All those things were added. And it is in progress. It is not like it has stopped there. Now their team is working on different features, and then loop version. This was just a branch version that I am basically talking about. Next. So as we see, I mean, as I mentioned that JalTantra got impactful research award in IIT Bombay, and then actually you see the real world impact. Many engineers have been using it, and then it was trained. For example, this Mitra, which was responsible training MJP engineer, has been integrated JalTantra to their curriculum, and then training is taking place. And then under Unnat Maharashtra Abhiyan in July 2017, we had taken a workshop at RIT Sangli, and then follow-up workshop at Amrit Vahini in January 2008 for empowering UMA colleges to conduct third-party technical audit of rural water supply schemes, like we had been doing for Palghar and Thane. Similarly, they can do it for their respective district. Similarly, other, those rural water supply engineers also, training had been done by technology development solution cells. And then there was a compendium with UNICEF. When we did this training, there is a compendium that has been actually developed as a training material for the capacity building both faculty and students of engineering colleges for improving the performance rural water supply and sanitation. So they can go out and then they can interact with their regional agencies, and then they can actually, basically using this training, they can use JalTantra for designing, optimization, etc. And then there is a active JalTantra user group of actually practicing engineers. It is continuously, actually different types of issues, different types of feedback has been coming. And then um, Nikhil is in, actually actively, is with them, and then he helps them out, or he helps them solve their problems whenever they encounter it. And also multiple workshops that have been conducted in JalTantra. And lastly, I should mention that when this particular scheme that we are working on is for Mokhada, now later on, it basically taken up by MJP. After they did physical survey, they have developed a DPR in about 2 years back, and that DPR is going further. And today only I got a message from Arun Nirbhavne, who is the executive engineer at Thane MJP, and we had different meetings. Many times we had met with collectors of Palghar uh, about this scheme, taking this further. So today only he said that that this scheme now again it is to be presented again to the government with the new norms. So that is a really and then this scheme was developed by themselves. This DPR was developed by using JalTantra. So that is like, some kind of climax, we can say, that the actual real world usage or impact of this particular tool and the innovation that we are trying to develop as a sustainable solution to people of Mokhada. So though it is like a big, those two have been basically converged together. So it is a great moment for all of us. I mean, so not only this particular tool, JalTantra, Professor Damani was saying that it is being used internationally. Some people, because it is freely available in Indonesia, they are using it. So that is again a test that the popularity of this JalTantra is growing not only in India but also in international area. Next. So this is the just the, because we are talking about this one, so bulk water grid that based on Upper Vaitarnath solution that we developed. It is a grid solution. Typically in multi-village scheme, what happens is that one village actually when it stop payment, then there is a cascading effect, and then other villages stop paying that, and the entire scheme collapses. To take care of that, and from the lessons from the earlier experience, we said that key, let us develop this as a grid solution, so that the basically backbone which is there, it is like any other grid, and the villages, individual villages can be connected or disconnected, and the bulk water meter will be there, through which that each village will be given certain quota of water, amount of water that they demand, and the management of that village will be left to those individual villages. So that way the problem separation is there, and then we can leverage the investment which is made by those villages. And actual important thing about this particular bulk water grid that we developed, it was just 1% of water being supplied from this middle Vaitarna to Mumbai. So you can see the value of this scheme in terms of the water deprived people of Mokhada. If his scheme actually implemented, then the value that people will get out of this with such a just 1% of the water. And in inclusive development, that should be taken going forward as a part of this project, that whichever the villages are affected, those should be, their drinking water needs should be part of the project. That is the new basically thing that should be taken up by the government, that we have requested to the government. Next. So, as I said, going forward, any other places also, the hybrid solution, many of the places only groundwater based schemes are there, and then they dry up and the schemes actually fail. So going forward, I think that both surface water and groundwater, that combination solution should be a way forward. And then size and capacity of grid, it will depend on the local conditions. And this grid concept, it should not be limited to only drinking water. Now, already we have some, we see that, extreme weather conditions are there, extreme floods are there, extreme drought is there. So taking into account this, climate changes impact, going forward, we can, leverage this kind of a concept to provide water to drought affected area from the excess water area, so the problems from both sides can be managed. And then sustainability, which will be ensured, to all the people and equitably. It is not that only a few people, but it will be all the people. That has been, basically proven by this Mokhada scheme, that solution that is developed with this state of art tool that was developed through this stakeholder engagement and continuous engagement. So that's all actually. So bottom line in this, the message for UMA colleges is that, I mean, as we said that the UMA philosophy I already said. So in that context, all the UMA colleges, and then proactively they should go ahead and then, try to identify the problems in their area through whatever means. Their student composition, most of them are coming from rural areas, and doesn't have to be a very big kind of solution. It can be start with the small problem, but innovative solutions problem. So that way students will learn while they are studying it. That time only they can earn something. His philosophy of Karmavir Bhaurao Patil was that earn while you learn. So here now going forward, we have to say that you earn the knowledge and create value while you learn. So while you are in college, that time is the actually time where you can actually create value for yourself and the society. And through these linkages and through this proactive work by these engineering colleges and the students and faculty, that's basically all the tomorrow is we can envision Maharashtra or India with the development of all the sections of the society, especially those which are actually the deprived section, underprivileged section. They will also be part of this development. Thank you.
Thank you very much, sir, for your enlightening speech. Of course, JalTantra is a need-based innovation, and it has been innovated with the rise due to the motivation that has caused to end the scarcity of the villagers in the Mokhada Taluka. Well, I should mention the presence of few of our colleagues from Unnat Maharashtra Abhiyan from all over the state of the Maharashtra. That is, we have Snehal Gujarati Madam who is representing Garda Institute from Konkan. Dhanraj Patil sir from Varnanagar, Vidyanand Kadam sir from Bharati Vidyapit College Kolhapur, T.S. Chaudhary sir, VJTI, Prashant Patil sir from Aurangabad, Gopal Chavan sir from Gopal Chawar sir, Jayashree Patil ma'am, Chandrasekhar sir, Swati Khedkar ma'am, and of course, the platform, the Unnat Maharashtra Abhiyan, is not dominated by the civil engineering department. It has been an interdisciplinary project. It is an interdisciplinary platform wherein it's a project which has been headed by Ministry of Higher and Technical Education. Of course, Center for Technology Alternatives for Rural Areas, that is Sitara, is the main brain behind this. Also, we should not forget the contribution of Osim Dharak ma'am. So this is how the team is working all over Maharashtra under the guidance of Rajaram Desai sir. Now I request Honorable in charge head of the department, Professor Shelar sir, to propose vote of thanks for today's webinar.
हॅलो, आज रयत शिक्षण संस्थेच्या कर्मवीर भाऊराव पाटील कॉलेज ऑफ इंजिनिअरिंग मधील सिव्हिल इंजिनिअरिंग विभागाने व IIT मुंबई उन्नत महाराष्ट्र अभियान यांच्या सहयोगाने जलतंत्र द स्टोरी ऑफ अन अवॉर्ड विनिंग इनोव्हेशन थ्रू एंगेजमेंट विथ स्टॅक होल्डर्स या विषयावर वेबिनार आयोजन केले होते. आजच्या या वेबिनार साठी उमाचे सिनियर प्रोजेक्ट मॅनेजर राजाराम देसाई सर यांनी फार मोलाचे मार्गदर्शन केले. सर, तुम्ही आज केलेल्या मार्गदर्शनाचा नक्की फायदा आम्हाला होईल. तरी देसाई सर यांनी केलेल्या बहुमूल्य मार्गदर्शनासाठी कॉलेजच्या व सिव्हिल इंजिनिअरिंग विभागाच्या वतीने मी त्यांचे मनापासून आभार मानतो. मुलांच्या प्रबोधनपर उपक्रमासाठी आम्ही नेहमीच आग्रही असणारे व त्यासाठी प्रोत्साहन देणारे आमच्या कॉलेजचे प्राचार्य डॉक्टर AC अत्तार सर यांचेही मी ऑर्गनायझिंग कमिटीच्या वतीने आभार मानतो. या कार्यक्रमाचे नियोजन सुंदररित्या ज्यांनी केले ते आमच्या सिव्हिल विभागातील प्राध्यापक डॉक्टर अनंत तपासे यांचेही मी आभार मानतो. या कार्यक्रमाचे सूत्रसंचालन ज्यांनी सुंदररित्या केले त्या आमच्या प्राध्यापक जगदाळे मॅडम यांचेही आभार मानतो. हा कार्यक्रम यशस्वीरित्या पार पाडण्यासाठी अनेकांनी विविध जबाबदाऱ्या बजावल्या किंवा बजावत आहेत की त्या सर्वांचेही मी मनापासून आभार मानतो. या कार्यक्रमासाठी उपस्थित असणाऱ्या सर्व विद्यार्थी बाहेरचे जे आहेत उमाचे व प्रतिनिधी व शिक्षक यांचेही आभार मानतो व प्राचार्य ऑर्गनायझिंग कमिटी यांच्या वतीने वेबिनार संपला म्हणून